Hi, my name is Venkanna Kota. Welcome to my YouTube channel Electronics for Gate by Kota Venkanna. Today I want to discuss in the GATE syllabus electronic devices subject. In the subject, first topic is energy bands in intrinsic and extrinsic semiconductors. Energy bands in intrinsic and extrinsic semiconductor. This is the first topic in the subject electronic devices. So before going to that, we have to discuss materials. In the electronics, basically materials are divided into three types. First one is insulator, second one is semiconductor, third one is conductors. Basically, materials are three types: insulator, semiconductor, conductors. So, first discuss about insulators. What is insulator? Here, insulator is a material which does not allow free flow of electrons. Such materials are known as insulators. And the outermost valence electrons of insulators are greater than 4. And the energy band diagram basically which consists of three bands. So here these are valence band, conduction band. In between these two gap is there. This gap is known as forbidden energy band gap. This gap is known as forbidden energy band gap. Example: rubber, paper, wood. So here the main bits covered here: material insulator, which does not allow free flow of electrons, and the outermost valence electrons of insulators are greater than 4. And energy band diagram which consists of three bands. First one is valence band, conduction band. In between these two gap is there, that is forbidden energy band gap. And example of insulators: rubber, paper, wood. For the insulators, the forbidden energy band gap, it is indicated with Eg. Eg is equal to 6 electron volts. Here 6 electron volts. So 6 electron volts is very high amount of energy. So that's why valence electrons are unable to jump from valence band into the conduction band. Why? Because here the gap energy is more. So that's why there is no conductivity. If we are applying external energy, then that energy also not enough to jump valence electrons into the conduction band. So that's why there is no conductivity. Conductivity is zero. So when the conductivity is possible, means when the electrons from valence band easily jump into the conduction band, then that is known as conductivity. But in insulator, the conductivity is not possible. Why? Because the energy band gap is more. That is, for the insulators, Eg is equal to 6 electron volts. Example: rubber, paper, wood. Next, coming to the point, semiconductors. So here semiconductors partially materials. What is semiconductor? The semiconductors, these are one of the materials. so which allows partially flow of electrons, which allows partially flow of electrons. So then these are known as semiconductors. Example of semiconductors, silicon, germanium, silicon, germanium. So the forbidden energy band diagram of here, the energy band diagram of semiconductors are looking like this, like this. So this is the bottom band is valence band and the top band is conduction band. In between these two some gap is there, that is known as forbidden energy band gap, that is indicated with Eg. Eg is equal to 1 electron volts. Eg is equal to 1 electron volts. So here for the insulators Eg is equal to 6 electron volts, very high amount of electron energy. But here for the semiconductors Eg is equal to 1 electron volts, 1 electron volts. And the valency electrons of semiconductors are exactly half of the maximum. So the maximum valence electrons 8, half of the 8 is equal to 4. So that's why the valence electrons of semiconductors are exactly equal to 4, exactly equal to 4. And here semiconductors example of semiconductors, silicon and germanium. At room temperature Eg is equal to 0.785 electron volts for germanium and Eg is equal to 1.21 electron volts for silicon. So at room temperature Eg is equal to 1.1 electron volts per silicon, Eg is equal to 0.72 electron volts for germanium. Look at this. At 0 degree Kelvin for the germanium Eg value and forbidden energy band gap 0.785 electron volts. At room temperature Eg value for the germanium 0.72 electron volts, that is decreases, Eg value decreases and forbidden energy band gap decreases at room temperature. Why? Because silicon or germanium, these are the examples of semiconductors. So semiconductors sometimes acts as insulators and sometimes acts as conductors. So at room temperature silicon or germanium semiconductors are acts as conductors and at 0 degree Kelvin semiconductors are acts as insulators. Why? Because at 0 degree Kelvin there is no energy, and at room temperature which requires energy, valence electrons acquire energy from thermal energy. So that's why due to the thermal energy these valence electrons are easily jump into the conduction band. So here at room temperature semiconductors are acts as conductors and at 0 degree Kelvin semiconductors are acts as insulators. So that's why these are known as semiconductors, of conductors, and sometimes acts as insulators, sometimes acts as conductors. So here these are the very important values. At room temperature Eg is equal to 0.785 electron volts per germanium, Eg is equal to 1.21 electron volts per silicon, and at room temperature Eg is equal to 1.1 electron volts per silicon and Eg is equal to 0.72 electron volts per germanium. So this is very important. And next discuss about materials are conductors. So conductors materials, these are which allows free flow of electrons, which allows free flow of electrons. Such materials are known as conductors, which have less than 4 valence electrons. So valence electrons less than 4, less than 4 valence electrons. The conductors of valence electrons are less than 4, and the energy band diagram of material or conductor is looking like this. So this is the valence band, this is the conduction band. In between these two, forbidden energy band gap is not there. Forbidden energy band gap is not there. Why? Because valence band overlap into the conduction band, and conduction band overlap into the valence band. So that's why valence electrons are easily travel from valence band into the conduction band. So that's why conductivity is possible. Always it is conductivity. Always the conductivity is maximum, infinity. So valence example, iron, silver, copper, etc., etc. These are the examples of conductors. So this is about the energy band diagrams of materials. Energy band diagram of materials. So for any daily classes, for any updates, for any daily classes, subscribe my channel. My channel name is Electronics for Gate by Kota Venkanna. So for the daily classes, in order to improve the gate, definitely subscribe my channel. The interested students must subscribe my channel, Electronics for Gate by Kota Venkanna. So the main points in this first main points are here. Main points, the important points in the gate point of view. So here materials are basically three types. Insulators, the valency electrons of insulators are greater than 4. So Ag value, the forbidden energy band gap. What is forbidden energy band gap? In between valency band and conduction band some gap is there. That gap is known as forbidden energy band gap, that is indicated with Eg. Eg is equal to, what is the value of Eg for insulators? Eg is equal to 6 electron volts. And example, rubber, wood, paper. So here insulators does not allow flow of electrons. And semiconductors, what is the valence electrons of semiconductors? Exactly equal to 4. So what is the value of Eg for the semiconductors? 1 electron volts. 1 electron volts. Next, at room temperature, what is the Eg value of silicon? Silicon Eg value is equal to 1.1 electron volt for silicon. Eg is equal to 0.72 electron volts for germanium. At 0 degree Kelvin temperature, Eg is equal to 0.785 electron volts per silicon. Eg is equal to 1.21 electron volt per silicon. Eg is equal to 0.785 electron volt per germanium. Okay, at room temperature, note this point, at room temperature, semiconductor acts as conductor. At 0 degree Kelvin, semiconductor acts as insulator. Next, coming to the point in gate point of view. So in the energy band diagram of conductors, overlap, valence band overlap into conduction band overlap into valence band. And example, iron, copper, silver, etc. So valence electrons of conductors are less than 4. So this topic is over. In the next class we have to discuss about a brief discussion of semiconductors. Thank you. Subscribe my channel. My channel name is Electronics for Gate by Kota Venkanna. So my name is Venkanna Kota. Subscribe my channel for daily classes. Thank you.